Today, we're going to talk about graphics cards. Graphics cards are an essential component of any gaming PC, and they can make a huge difference in your gaming experience. In this video, we'll cover everything you need to know about graphics cards, including what they are, how they work, the history of the graphics card. Let's take a look at the technology behind it. Graphics cards, also known as video cards or GPUs, graphics processing units, are hardware components that are responsible for rendering images, videos, and animations on your computer screen. They work by taking the data from your computer's CPU and turning it into images that can be displayed on your monitor. Graphics cards are also used for gaming, 3D modeling, video editing, data mining, and many other tasks. The two main manufacturers of graphics cards are Nvidia and AMD. Other hardware manufacturers like Intel also have their own integrated graphics cards. Graphics cards are essential components of any modern computer system that enable us to see images on our monitors. But how do they work? What are the main parts of a graphics card and what do they do? In this video, we will answer these questions and more. A graphics card is a device that takes binary data from the computer's central processing unit, CPU, and translates it into visual information that we can see. The CPU sends information about what to display on the screen to the graphics card, which then decides how to use the pixels on the monitor to create the image. The graphics card also adds lighting, texture, color, and other effects to make the image more realistic and appealing. A graphics card has four main components: a motherboard connection, a graphics processor, video memory, and a monitor connection. The motherboard connection is where the graphics card gets data and power from the rest of the computer. The graphics card usually connects to the motherboard through a PCIe X16 slot, which provides high-speed data transfer and enough power for the graphics card to function. Video memory, or VRAM, is where the graphics card stores information about each pixel and temporarily holds completed images before sending them to the monitor. VRAM is faster than regular RAM because it is dedicated to the graphics card and has a wider bandwidth. The amount and type of VRAM affect the performance and quality of the graphics card. More VRAM means more space for storing complex images and textures, while faster VRAM means faster data transfer between the GPU and VRAM. The monitor connection is where the graphics card sends the final image to be displayed on the screen. The monitor connection can be different depending on the type of monitor and cable used. Some common monitor connections are HDMI, DisplayPort, DVI, and VGA. The monitor connection also determines the resolution and refresh rate of the image, which affects how sharp and smooth it looks. Depending on your needs and budget, you can choose between two types of graphics cards, integrated or discrete. Integrated graphics cards are built into the processor and share system memory with the CPU. They are cheaper and consume less power than discrete graphics cards, but they also have lower performance and quality. Integrated graphics cards are suitable for basic tasks like browsing the web or using office software, but they may struggle with demanding games or applications that require high-end graphics. Discrete graphics cards are separate devices that have their own GPU and VRAM. They are more expensive and consume more power than integrated graphics cards, but they also have higher performance and quality. Discrete graphics cards are ideal for gamers or professionals who need advanced graphics capabilities for their work or entertainment. Graphics cards are amazing devices that enable us to see images on our monitors. Depending on your needs and budget, you can choose between integrated or discrete graphics cards for your computer system. But how did video cards become so important? Let's take a look at the history of video cards. Graphics cards first appeared in the mid-1980s as simple graphics adapters used to send images to computer monitors. These graphics adapters could only display the basic colors and straight lines. In the late 1980s, the first color graphics cards were released, which could create more realistic images using a palette of 16 colors. However, the development of graphics cards began a revolution in the 1990s with the Video Graphics Array, VGA. VGA was the first graphics card capable of producing 256 color images, enabling the creation of more realistic images. Additionally, VGA increased the graphic potential of computers by providing higher resolutions and better color palettes. In the late 1990s, the popularity of 3D games increased, leading to a greater need for powerful graphics cards. As a result, companies such as Nvidia and ATI, later sold to AMD, began producing high-performance graphics cards. In the early 2000s, Nvidia's GeForce and ATI's Radeon series became the standard for PC gamers. These cards were developed for higher frame rates and resolutions. In the early 2010s, innovative technologies such as Nvidia's Kepler architecture and ATI's GCN architecture once again increased the performance of graphics cards. These architectures provided lower power consumption and higher performance. Today, Nvidia and AMD produce some of the most powerful graphics cards for PC gamers. Additionally, integrated graphics processors are becoming increasingly powerful, allowing some gamers to achieve high performance without purchasing a separate graphics card. Graphics cards are also widely used in other areas. For example, they are used in scientific simulations, artificial intelligence processing, and video editing, all of which require high performance. From the first graphics card to the present day, we have a monster like the Nvidia RTX 4090, which is the most powerful graphics card produced for computer users. Let's briefly examine the huge difference between the first graphics card and today's monster, the RTX 4090, to better see the pace of technological progress. The IBM MDA is a simple graphics card that can provide monochrome and low-resolution images. The GPU speed is 4.77 MHz. The image memory is only 4 kilobytes. The RTX 4090, on the other hand, is powered by Nvidia's Ada Lovelace architecture and has 24 GB G6X memory. The GPU speed is 2.2 GHz. It also supports advanced technologies such as ray tracing, DLSS 3, and Nvidia Reflex. Comparing the first graphics card to today's most powerful graphics cards is quite difficult. This is because graphics cards are no longer just about hardware power. Nevertheless, we will use the following formula to roughly calculate the power difference. Power difference will be calculated with GPU clock speed difference, GPU memory amount difference, memory clock speed difference, and technology performance increase. It's a very relative concept, but for the sake of fairness, we will base the performance on the FPS increase coefficient shown by the DLSS 3 technology in games. DLSS 3 technology provides approximately 3 times FPS increase in games. GPU clock speed difference, RTX 4090 has 2.2 GHz base frequency while IBM MDA has 4.77 MHz, equals 461 times. Memory amount difference, 4,024 GB. IBM MDA for kilobytes, equals 6 million times. Memory speed difference, 21 gigabits per second, 4.77 MHz, equals 4,400 times. Power difference, 461 by 6 million x 4,400 times 3 is equal to approximately 27 trillion times. In conclusion, we can say that there is a power difference of approximately 27 trillion times between the RTX 4090 and the IBM MDA. This is a clear indication of how far technology has advanced. The journey of computers, which started with simple machines that can perform calculations or repeat basic patterns, has now turned into a massive industry. The graphics card industry, Nvidia, which is today's leader in the graphics card industry, released its first graphics card only 24 years ago. As we follow the technology and history of computers and graphics cards in this video, we see once again that the pace of technological advancement continues to surprise us every time we look. Thanks for watching. Please don't forget to subscribe, like, and share with your friends. You can write your thoughts and ideas about the video in the comments. See you next time.